involutive. Another type of matrix will be there, like null point matrix, null point matrix. Nilpotent. Nilpotent কি বলছে? Let if let a square equal to 0, then A is called nilpotent of order 2. If A cube equal to 0, then A is called nilpotent of order 3, and so on. So another type of matrix will be there. One is called involutory matrix. That is when A square is equal to I. Only A square, not A cube. Only A square equal to I. Then A is called involutory. For the case of nilpotent may be of different order. If A square equal to 0 matrix, or A cube, then a nilpotent of order 2. If A square equal to A cube equal to 0 matrix, nilpotent of order 3, and so on. Now the transpose. Now the another part. Transpose of a matrix. That is, you can say, interchanging, in short, interchanging row and column. Let us start with an example. Let A equal to, just write it, 2, 3, 1, minus 1, 0, 1. Find transpose of A. Okay. Find transpose. They're quite simple. The solution. What is the meaning of transpose? Transpose is another matrix. AT represented by AT, A transpose. That is just write 1, 2, 0. This column representing row like this, and row representing. So this is simple concept. This column representing as row, and this column is representing as cell. Okay. So this is here. So this is called transpose of a simple row column in interchange. So naturally, we have another exercise. For example, find AT, A transpose, when A equal to 2, 0, minus 1, like 0, minus 1, 3, 4. Find AT. B, sorry, another say find AT BT, and say B equal to, like it, 1, 2, 3, 4, 5, 6, minus 1, 0, 2. Another CT. Let C equal to say right, 1 0 1 2 minus 3 minus 2 3 4 0. So at the beginning we write, try to find 80 solution. 80, just row column row. So for case of 80 we write 2, this is the row, and in 0 minus 1, right? 2 0 minus 1 is the column, so it is replaced as a row. 2 0 minus 1. Okay, how is it? 2 0 minus 1 টা কলাম আছে, সেটাকে রো করে দিলাম, ট্রান্সপোজ তো উল্টে যাবে। 2 0 minus 1 টাকে উল্টে রো করে দিলাম। ওকে, ন্যাচারালি সেকেন্ড কলামটাকে উল্টে রো করব। নাও সেকেন্ড কলামটাকে উল্টে রো করব। তো 0 3 4, লাস্ট থার্ড কলামটাকে উল্টে রো করব। So that is -1 4 and 5. Okay, so this is the 80. Similarly we can write BT also. Similarly we can write BT. Let's just write it 1 4 minus 1. Just write this column 1 4 minus 1. Column wise check देखो, row wise लिख दीजिए. Okay, then 2 5 0. Second column is interchange as second row. Then 3 6 2. Okay. Now CT. Again, if you go for column is replaced by like this -2 3, then this 2 0 minus 4. Okay, then this -3 4 0. Here মজার জিনিস যেটা দেখা যাচ্ছে, দিস ইজ ট্রান্সপোজ। মজার জিনিস দেখো, here you see A equal to 80. ভালো করে দেখো, A equal to 80. After transpose, the basically A or 80 both same. You see that A equal to 80, but case of not B equal to BT, you see this. চাইলে দেখতে পারো, not B equal to BT, B equal to BT নয়, C equal to CT নয়, ভালো করে দেখো, but A equal to 80. But B not equal to BT, but you can say CT is not equal to C. Luckily, সবসময় যে হবে বলছি না, কখনো কখনো হতে পারে। If so, we get a conclusion. If for a matrix,
the first row and first column equal হলেই হবে।
বলছি যদি হয়, if for a matrix A we have A equal to 80, then A is called symmetric matrix. মবিকা, কথা তো বলা যাবে না বাবা, ক্লাস অ্যাটেন্ডিভ থাকতে হবে তো, কথা বলবে, অ্যাটেন্ড সবকিছু হবে নাকি? আচ্ছা, then A is called symmetric matrix. SYMMETRIC, symmetric. If this property holds, that is A is equal to A transpose. If maybe সবসময় ভাবি যান, say for example B is not symmetric, you see this quite clear. B is not symmetric because B transpose is equal to not equal to B. C is not also symmetric because C transpose is not equal to C. সবসময় হবেই যে বলছেন, if it is possible, if it is valid, or rather if the equation is valid, like A transpose is equal to A, then A is called symmetric matrix. Okay. Now, again, we see B not equal to BT, C not is equal to C. Sorry, C not is equal to CT, B not is equal to BT. We to see this again. See that. Check that. Minus CT. What is the value of that minus CT? Let us CT is this. If we put if multiplied all equation by all elements by a minus, what we have? 0 minus 0 is 0. 2 minus 3.
Minus 3.
Remember,
minus 2.
remember the scalar multiplication. Actually, we have multiplied by minus 1, right? Minus 2, 4, 3, minus 4, and 0. And you see, we have nothing. Actually, get C. What do you get? C. Although you see here, CT is not equal to C for this case. CT is not equal to C. But if luckily, if we multiply the CT with minus 1, we get C. Maybe আবার বলছি সব সময় it is not possible. Maybe for some particular matrix it is true, maybe for another matrix it is not true, and so on. But if this property holds for any matrix, now we write if for a matrix A we have 80 minus 80 equal to A, or you can write simple 80 equal to minus A, একই ব্যাপার. Then A is called skew symmetric matrix. So দুটো definition আমরা শিখলাম. One is called skew symmetric matrix, one is called symmetric matrix. Symmetric matrix means transpose is equal to A. And skew symmetric means transpose equal to minus of A. Just the almost same, but okay. For the case of skew symmetric matrix, transpose is equal to A, but for the skew symmetric matrix, transpose is equal to minus A, and the symmetric matrix transpose is equal to A. Simply minus plus are only differences, minus and plus. Luckily, in our example, B is neither symmetric nor skew symmetric. Luckily, in our example, B matrix, this is B matrix. B is neither symmetric nor skew symmetric. So, একটা matrix যে symmetric হবে এমন কোনো কথা নেই, skew symmetric হবে এমন কোনো কথা নেই. Maybe it's symmetric, maybe it's not symmetric, maybe neither symmetric nor skew symmetric. If the property holds, then it is called a symmetric matrix. If it is not, then it is not symmetric matrix, and so on. Clear? Symmetric হতে হবে এমন কোনো মাথা ব্যথা নেই. আবার বলছি, skew symmetric হতে হবে এমন নয় যে symmetric না হলে skew symmetric হবে. No, a matrix may be not skew symmetric, maybe not symmetric, maybe simple like a matrix. But if this property holds, then it is called skew symmetric. Like this. যেরকম আমরা একটু আগে পড়েছিলাম, সব ম্যাট্রিক্স কোথায় গেল? সব ম্যাট্রিক্স যে involutory হবে এমন not necessary. If this A square, for if we multiply A into A and we get identity, then that matrix is called involutory. If we multiply A into A and we get the zero matrix, all zero, কোনো একটা multiplication respect যদি পাই, then we call that matrix is called nilpotent of order 2. Naturally, nilpotent of order 3. Okay. Similarly, if we get A square is equal to A like this, then A is called idempotent matrix. It is just naming convention. মনে রাখার সুবিধা দরকার. ওকে, আজকে আমরা ইনভার্স পড়বো না, পরের দিন পড়বো, সময় লাগবে ইনভার্স. এমনি কেউ ক্লাসে অ্যাটেন্টিভ থাকে না, ঘুমায়. ওকে, অ্যানাদার টার্মটা একটু শিখে বন্ধ করি. থাক, স্কিউ সিমেট্রিক ম্যাট্রিক্স বলতে থাক, পরের দিন আমরা স্কিউ সিমেট্রিক ম্যাট্রিক্স যাবো. ইনভার্স আজকে আর হবে না, ইনভার্সটা পরের দিন করবো।